Hey guys, so I'm going to give this a go. First time I've done this, but I've had quite a few emails today and yesterday about the Surds stuff, particularly videos 113 and 114 on Hegarty. So that's your multiplying and dividing with Surds. So I'm aware hopefully you will have watched the video on there, but I just wanted to talk through it basically just in case you wanted an extra one. So 113, multiplying Surds. If this is working, first time I say I'm doing this, you'll hopefully see my screen in the bottom left of this, and you'll hopefully see what I'm working out here on the right. I'm not exactly a streamer, so we'll see how this goes. So we can see some examples here. You might not be able to see them, so I'm going to rewrite them out. Our rules of Surds basically are that root A, the root of some number, times the square root of another number is the same as the square root of both of those, the product of whatever those numbers are. So root A times root B is root of AB. In other words, if we have root 3 times root 6, then 3 times 6 is 18, so that is the same as root 18. And we can go backwards from these. In the same way that 3 times 2 is 6, well, if root A times root B is root AB, then you go backwards. Root AB divided by root B would give you root A, and root 18 divided by root 6 would give you root 3, in the same way that 6 divided by 2 would give you 3, and so on and so forth. So our division rule, therefore, is that root A divided by root B is root of A over B. It's the same thing, but just backwards. So sometimes the examples on the board at the moment, I say on the board, you know what I mean, are root 2 times root 8, and 2 times 8 is 16, so it's root 16. The next one down, root 5 times root 20, 5 times 20 is 100, so root 100. We keep going down, we get root 2 times root 32. Well, 2 times 32 is 64, so we get to root 64. Now, the thing with these three is all of these numbers, 16, 100, and 64, should be sticking in your head here and sort of triggering you. Whenever you're messing with Surds, don't feel ashamed if you start writing your square numbers down at the top. So square numbers, 1 times 1 is 1, 2 2s are 4, 3 3s are 9, 4 4 is 16, 25, 36, 49, 64, 81, 100. Know them preferably up to your 1212s. And by just having them at the top of your screen, they're there as a trigger. So if you know that if 16 is a square number, then obviously root 16, we can simplify that to just 4. We can simplify the square root of 100 to just 10, because 10 times 10 is 100. And we can simplify root 64 to 8. So that's your absolute basics of simplifying Surds. Now, I'm hovering over these preview questions here that you might get asked in this one. So let's see. Yep, so sorry, just totally planned this, absolutely, not just done it on a whim. So on this one we got root 8 times root 2, which I've just done there the other way around, so we've talked through that one. Next up, you can get bigger numbers, so root 24 times root 6. Now, there's two ways of going about this. The longer way, which is always going to get you the right answer, it might just involve more steps, is do exactly what we've done here. 24 times 6. 2 6s, 12, 1. This is where I should pause the video, but it's been that long since I feel like I've done maths myself. 6 20s are 120, 6 4s 144. If I'm wrong on this one, I'm going to cry later. So, 6 times 20, 120, 6 times 4, 24, 144, absolutely. And there you go, 12 12s. So we're just going to simplify that one back down to 12. So let's go back to Hegarty then. We're done. We go backwards and do some division. Root 40 divided by root 10. Well, our rule here said that the root of one square root, one square root divided by another square root is the same as the square root of just the division. So 40 divided by 10 is 4. So they're both surds, so root 4. And since we're triggered, we see 4 there, root 4 is 2. And we can simplify it. Why would we ever want to try and do all this? Why can't we just leave it as it is a really good common question. We love surds. They're exact. They're perfect. The moment we stick that in a calculator, root 18, we can turn it into a decimal, but it's going to lose all its accuracy. So by keeping it as root 18, it preserves this perfection, the actual number, without ever rounding it unnecessarily. So what else we got on this one then? Big numbers, I suppose, there. So, okay, so the next one that I've just slipped past is square root of 192 divided by 3. And already it looks pretty horrific because none of those are on my square numbers list at the top. But it doesn't give you a question that it's impossible to do, so we're just going to do the division. So, how many 3s are in 1? None. How many 3s are in 19? 6, carry the 1. How many 3s are in 12? 4. And we've just done a square root divided by a square root. So 192 divided by 3 is 64. It's root 192 divided by root 3, so root 64. Once again, there's our square number, 8. Let's see, what else can we do? That's pretty vile. Root 8 times root 1 over 98. Let's see how this